Hiya. In this video I'm going to talk to you more specifically about the least squares regression line. Now if you've not seen my first video on Introduction to Scatter Graphs, then I suggest you actually do that, because in that video I explained to you where we get to in terms of why this is a regression line and the initial stages of actually calculating it. What I'm going to do in this video is just show you the formulae effectively and give you some examples. Okay, so watch the other video if you want to see the introduction leading up to this point. Okay, but we got up to this stage that the regression line is y equals a plus bx. What we need to do now is know how to actually calculate it, because traditionally you calculate it first from the actual given data and then, if necessary, you draw it. Okay. But the drawing will only be for pictorial representation. Once you've got the equation, that's all you need for any calculations you need to know. Okay. Now, as a reminder, you have these summary statistics here. You might remember this one here from the standard deviation units that you did much earlier on, I hope, in that the standard deviation is basically SXX over n and then square rooted. Okay, but as a reminder, SXX as a summary statistic is sigma x squared subtract, and then this fraction here, sigma x all squared over n. Similarly, the statistic SYY is exactly the same as that, but y squared instead of x squared, sigma y instead of sigma x. Okay, and then the third summary statistic you need is this SXY, which instead of x squared is xy. Combination of the two, you can see, and instead of sigma x times sigma x, it's sigma x times sigma y over n. So you need to know those summary statistics in order to be able to calculate the least squares regression line, and for the PMCC, which will be coming up later as well. Okay. Now, first of all, you work out b, which is the gradient of the line, and that is calculated by finding SXY over SXX. So that's it. So first of all, you need to work out what that is, and then you'll need to work out this is, and then just have one divided by the other. That is it. Okay, that's all you need to do. And then for a, you just need to effectively rearrange this equation here. You need to make a the subject. So if you bring the bx to the other side, you'd have a is equal to y minus bx. Okay, and then to work out what a is, you'd substitute in the value of b you'd found from this calculation here, and then you substitute also the mean value of x and the mean value of y. In other words, for your data variables x and y, work out the mean, or you'll be given what it is and you substitute in and work out what it is. I hope you can see a consequence of that is, once you've worked out a using that, is that this regression line will go through the mean point. Okay, I'm hoping that kind of makes sense to you. In order to keep these distances, the squared distances, minimised, that is the average squared distances minimised, then the regression line is going to go through the mean point. I'm hoping that makes some sort of sense for you. But those are the formulae. You probably want to make a note of it. I'm about to take you through some examples of how they work. Okay. Okay, so here's a worked example involving the equation of a regression line. It's quite worded, isn't it? But I want to put it all on one board before I start to work through it. So traditionally, this is what a set of data looks like. You can see there's 5 paired variables, okay, and one is about mass, one is about length, okay. So it could be that you've got items of a particular mass are attached to a length of string or rubber band, whatever, and the amount that the rubber band stretches, or I call it a spring because it could be a spring, the amount that this thing stretches is given by length, which is this, okay? So it kind of makes sense, doesn't it, really? So the heavier the mass, the longer the band, spring, whatever it is going to stretch out, okay? But it doesn't really matter, as long as you've got the data values, okay? Now, sometimes you're given these in order to help you out, okay? There's a lot there. That's part of the challenge of statistics. You've got to be able to interpret everything and know what to use and what not to use, okay? So you're given these for the x variables and these for the y variables, and you're given sigma x, y as well, okay? Here's the actual question. Calculate the regression line y on x, okay? So it's normally called y on x when x is the independent variable and y is the dependent variable, okay? And then use this regression line to predict the length when the mass is 58 kilograms or 130 kilograms. So if you can't do that, then you're not going to be able to do those, are you? But that's the whole point of the regression line, so you need to try and make predictions for this. And then finally, comment on the reliability of each. Well, actually, before I go through the question, we can answer that one straight away, can't we? Remember I talked about interpolation and extrapolation? We'll look to see whether either of those, or both of them, or none of them, fall within the data range. So 58 kilograms as a mass. So yeah, that lies in the data range, doesn't it? So it seems that that's going to be fairly reliable. Okay, 130 kilograms, however, does not lie within the data range. So that does not appear that it's going to be as reliable. So the answer to this one is reliable because we can use interpolation. It's within the data range. It's best to say all of those to guarantee yourself a mark in an exam. And this one, unreliable because it is not within the data range. You have to extrapolate. Okay, so you can always answer that one even if you can't do those. And that's just worth probably a couple of marks. That's it. Okay, right, let's get on with answering this one. Calculate the regression line y on x. And if you don't mind, to do it, I'm going to make some space and I'll come back to the other part of the question afterwards. Okay, this is a bit of a difficult video for me to get through because things just keep on happening. The noisy vehicle, that was outside. Okay, and I looked up just a few moments ago and my camera was no longer pointing towards me. I knocked it over by mistake. So sorry for the stops and starts and the editing. It's just, yeah. Okay, so what I was doing, I was just rubbing this off the board, wasn't I? Okay, to make way for some working. And what we need to do, of course, is calculate this. Okay, the equation of the regression line is that a plus bx, and the first thing to do is work out b's. Okay, so that's what I was about to do. Just my camera fell over. Okay, so you've got s, x, y there. And I'm going to substitute these values in, okay? You don't need to copy it out again, that wastes time in a particular exam, but if you're taking notes on this example, then yeah, just copy out what that is, okay? So sigma xy, and this is where you make use of this. You can see how handy that is. If that's not given to you, then you're going to have to use these data values to calculate them, which is quite time consuming, isn't it, really? So the idea behind giving you these is to try and take the sting out of the time consuming element. Let's face it, statistics is a very laborious and time consuming thing, isn't it? Yes, it is. Okay, but you need to be able to do it to pass your A-levels. Yeah, so SXY, so that's going to be that one there first, sigma xy, so that's 18,238, and then subtract sigma x times sigma y, so 300 multiplied by 288.6 divided by n, and we can see there's 5 data values. Okay, so the first thing to do is calculate that, and oh god, so nothing's going right. I just dropped my calculator. Let's just work out what that is. So 18,238 subtract 300 times 288.6 over 5. Make sure I typed it in properly. And, 922. It's nice when it's an integer. Okay, 922. And so next we need to work out SXX. So I'll just put that down by here. SXX. So that's sigma x squared. So it's that 22,000. And then subtract sigma x all squared. So that's 300. Squared over n, which is 5. So nicely, as a reminder there, the difference between sigma x squared and sigma x all squared. Sigma x squared was that, and then sigma x all squared is that squared. Okay, and then I'll just use my calculator to work out what that is. So you've got 22,000 subtract 300 squared divided by 5, and that turns out to be 4,000. Okay, so there we go, another nice whole number. Okay. So what that means is that B is going to be equal to sigma xy over sigma xx. So 922 over 4,000. And that's probably something that will simplify. And not by much really. 461 over 2,000. Okay. So I'm going to get rid of this now. Hope you don't mind. I'll put it down by there this time so I don't interfere with the camera setup. So as a decimal, I've got 0.2305. Now in mathematics, pure mathematics, I mean, fractions are normally best, okay, because we're dealing with accuracy when we're dealing with that. In terms of statistics, Quite a lot of the time decimals are the preferred notation to use. You decide which one to use. I still go for fractions because I'm more of a pure mathematician. You've probably sensed that about me. Okay. Mainly just my flippant comments about statistics. Okay. Off camera mainly. Okay. And yeah, but sometimes decimals, if it's an exact decimal, I'd write it in. That is exact, 0.2305. If it was an awkward decimal with so many decimal digits, I wouldn't bother, I'd just use the fraction. Okay. So that's what B is, okay? Now remember how to work out what A is? You've got A is equal to, so you rearrange the equation, y minus B x, okay? And then you just put in x bar and y bar, okay? So y bar is given to us, 57.72, subtract B times x bar. So that's 60, isn't it? Times by this value there. So I'm going to write the fraction in if you don't mind. 922 over 4,000 multiplied by 60. Okay, and I'll write down what that gives us. So 922 divided by 4,000 times by negative 60 added to 57.72. 43.89. You can write it as a fraction if you want. That's exact 43.89. Okay, so let's just squeeze it in down by here. Therefore, our equation of the regression line is y equals 43.89 plus 0.23. Oh, running out of space. Let's just rub that off. I know what the answer is now. 2305x. Okay, fine. I'm hoping that's okay for you. Okay. What I'm going to do next is I'm going to just rub this off. It's be time consuming, so I'm just going to pause the video. Okay, so that's me rubbing off the board. It's time consuming, you see. I just took the sting out of that by stopping the video for you. So we've got the regression line equation there. Now, if you wanted to draw it, you could do. Okay, that's not part of the question. What you notice is in an A-level exam, you're not often asked to draw a scatter graph with the regression line. Okay, it's enough just to be able to have it calculated. Okay, but pictorially, you could do it if you wanted to. Okay, but what we're going to use it for is a question like this to make some sort of prediction. Okay, so I've just reworded it. Okay, I've interpreted it because initially it said something along the lines of find the length when the mass applied is 58 kilograms and find the length of the mass applied is 130 kilograms. Put it in terms of x and y because the regression line is in terms of x and y. You've got to be able to do that. Okay. Basically, the question is saying find y when x is either one of those values there. Okay. And incidentally, if you're not given the x and y from the table, allocate the x and y. Okay, because that's what you'll need to be able to do. So what we're going to do is just going to substitute that value of x into this first. Okay. And then see what we get. That's all it is, just a bit of calculator work. Okay, in year 7 can do this. I'm not putting down year 7, of course. Okay, I'm just trying to make some sort of comment as to how ridiculously easy this bit actually is. Okay, and speaking by filling out this bit while I type in the calculator. So it should have y equals 57 point, it says 259. Let's round to 3.3, shall we? That means 3 significant figures. And put a unit as well. Now, because statistics, just like mechanics, is applied mathematics, okay, you should really put in the units where appropriate. Okay, so the length is 57.3 centimetres. And then we'll do the same for the second part. So here comes a simple bit of just substituting in. Multiply by 130 and then add 43.89 is equal to 73 point, let's put it as 0.9, shall we, centimetres. Okay, and that's all that is. Okay, and just remember the last part said to give some sort of indications whether these are reliable, and the answers are yes, that's reliable because it's within the data range, and no, that's not reliable because it was not within the data range. Obviously 58 sits within that, but it does 130 does not sit within that. Okay, so that's that question done. Okay, I'm just going to answer a couple of other bits that weren't in the original question. Okay, I'm just going to ask you to think about how you'd interpret both the y-intercept and the gradient. Okay, just have a think about that for a minute. if you want to make a minute, you can pause the video or have longer if you wish, okay? But I'm going to talk about it now, okay? So remember we talked about that being a y-intercept, okay? So in terms of a sketch, it would look something like this, wouldn't it? Okay, with a y-intercept of 43.89. That's your y, that's your x, and a positive gradient, okay? So the interpretation here is when x is 0, then y is equal to 43.89. Interpret it in terms of the context, okay? What that means is that when the mass is 0, so in other words, there's no mass attached at all, the length is 43.89 centimetres. So what that means is when there's nothing attached to this, whatever it is, spring or string or band, okay, when there's nothing attached, the length, okay, is 43.89 centimetres. So that's the interpretation of the y-intercept, okay? Then we look at the gradient, okay? Now remember, with gradient, and let's draw a bigger diagram, you calculate it by looking at the change in y over the change in x, okay? As long as you have that as a value of 1, then this value here must be equal to the gradient. Can you see how that makes sense? Because 0.2305 divided by 1 is 0.2305, the actual gradient, okay? So that's what I meant in my very first video when I said that you look at each unit along the horizontal direction on the independent axis, okay? And then you've got the gradient number of units vertically, okay? So the way you interpret this is as follows. For each extra kilogram, so for each extra kilogram of load that is attached to this spring or string, it will stretch by another 0.2305 centimetres. And that's how you'd word it, okay? For each extra 1 kilogram of mass that is attached, then it would stretch by a further 0.2305 centimetres. And that's how you'd interpret a y-intercept and a gradient, okay? I'm hoping you found that useful, okay? I'm hoping that you got a lot out of it, okay? Another example coming up. Okay, I've got one more example for you. So a lot less wordy this time, but I've just basically got down to the important bits of the matter, okay? All you need for an equation or regression line essentially is these bits of information here, okay? If you've not got them, you've got to be able to find them from the table, okay? But that's not what the example's about. It's how to use these once you've actually got them, okay? So the question is simply find the equation of the regression line, y on x, and of course write your answer in the form y equals a plus bx, and that's what we're going to do. So as a reminder here, that's the equation that we need. We need sxy, sxx in order to find what b is first of all. Sxy over sxx, okay? So the first thing we do is to work out s, and we'll do xy first of all. Doesn't matter what order you do it in, just that because it's the numerator, I'm going to do that one first, okay? So sxy is sigma xy, which is that one there, 140. Subtract sigma x, sigma y, so 10 times 48, 10 times 48, all divided by n, and we're given it here, n equals 4. And we're going to work out what that is, okay? So here I'm going to get my calculator, actually. 48 divided by 4 is 12, isn't it? And 10 times 12 is 120. 140 subtract 120. Didn't need a calculator on that occasion. Let's just put it back in. That's 20. And then sxx, okay? And we'll see what that is. So sigma x squared is 30. Subtract sigma x all squared, which is 10 squared, divided by n, which is 4. And we could probably do that one without a calculator as well, can't we? So 100 divided by 4 is 25, 30 subtract 25 is 5, okay? So that's that, okay? And so what that means then is that, I'll tell you what, I'm going to write it up here if you don't mind, just to save space really, because I'm going to put more calculation underneath. So we've got b then must be equal to sxy over sxx, so 20 over 5, 4. Okay? Isn't it nice when you can do questions without a calculator? Okay, so that's that. And then we've got to work out what A is. Okay, so remember to do that, we've got to do A equals y bar subtract b x bar. Okay, and one thing you'll notice that's not been given to us actually are x bar and y bar. So we've got to find them. Okay, we've got to find them. Okay, so let's just work out x bar is first of all. So remember, x bar is the sum of all x values divided by the number of values. So it'll be 10 divided by 4, won't it? 10 divided by 4. So that's 2.5. No longer got decimals, but that's fine. 2.5 or 5 over 2. Okay, I'll go for 5 over 2 if you don't mind. Y bar, similar thing. It could be the sum of all the y values divided by the number of values. So 48 divided by 4, so that's going to be 12. Okay, so that's x bar, y bar. So next, what we need to do to work out A, let me just get rid of this carefully so I don't knock my camera down this time. Okay, it's the first time I've knocked my camera by doing that, to be honest. So A is equal to y bar minus b x bar. Okay, and so that's what, 12 subtract 4 multiplied by x bar. That's funny, isn't it? Because we divided 10 by 4 in order to get it. Never mind. There we go. So of course 4 times that would be 10. 12 subtract 10 is going to be 2. Okay, so A is 2. So therefore our equation is going to be y is equal to 2 plus bx, where did I put b again? There, 4 plus 4x. Okay, and then that's it. That's our answer to this question. Okay, quite simple really, isn't it? Just a note on why I think it's written that way around, because you know we normally write y equals mx plus c for coordinate geometry. Why is this just being swapped around? It's just that sometimes you get a value of b that's negative. So for example, had b turn out to be negative 4, it would just make more sense to write it as 2 subtract 4x. Okay, you've probably done that in coordinate geometry. That's the only reason I can think of as to why it's written that way around. There's any logical reason to me anyway. Well, I'm hoping you enjoyed those examples. I'm hoping you got something out of it. Next thing to do, of course, is to practice. Practice as much as possible. Okay, I'll see you again.